another class of problems that we can do under the sort of general realm of conservation of momentum. And let's just start off with an example. I think the classic example is usually a cannon. So I'll draw a cannon. We know my artistry is not so awesome, but I think I can draw a cannon. I'm going to put the cannon on wheels just so it can move. It can move back and forth. I'm also going to keep the cannon shooting horizontally. And inside the cannon, of course, I'll put a cannonball. So I'll give us some numbers and then we'll work out what we want to work out of it. Let's say the mass of the cannon, that's the whole barrel of the cannon. We'll make it easy, 100 kilograms. And let's say the mass of the cannonball is also something easy, 2 kilograms. So there's our before picture. Then the cannon's going to get fired. So we got to draw the cannon again. Hopefully it looks the same as the other cannon. Great. And here's the cannonball. I'm going to say the speed of the cannonball is, we'll just keep the numbers really easy, 200 meters per second. What I want to find out here is, what's the final speed of the cannon itself? And we call that a recoil. A recoil speed or a recoil velocity. What's the speed of the cannon going back? Well, we're going to do the same thing here as we always do. We're going to start out with initial momentum and final momentum and set them equal to each other. And it's going to be a little bit easier to do. But I just want to start out here just because it's always instructive to remember that these are conservation of momentum problems, right? If we look at what the situation is before the explosion, you can see that nothing's moving. That means my initial momentum is going to be 0. That makes the problem actually really, really easy. Now on this side of the equation, I've got the cannonball and I've got the cannon itself. Well, the cannon itself is going to be 100 kilograms times VF. And now I have to add in the cannonball, which is 2 kilograms, and its velocity, which I know, 200 meters per second. Ran out of space there. Right. Now, easy. Solving this is really, really easy. I get 0 equals 100 VF plus 400. Subtract negative 100 VF equals 400. So my VF is negative 4 meters per second. Negative, well that makes sense, right? If we go back and look up here and we see which way is this guy going, well he's going backwards, so it's good that that ended up being a negative number, right? So these explosions problems are actually really easy to do, very, very basic, and just one of the key things to remember is that this initial momentum is 0. Now there could be some harder problems. For example, what if I started out with the cannon moving in a particular direction? Well, that might be a little trickier, but we'll leave it alone for that and just have an easy example.